So we covered this a little bit in that Intro to Calculator Basics video, but I just want to go a little bit more in depth about finding derivatives on our calculator and even interpreting them. So one thing that I like to do whenever I start a new problem is just go to Menu, Actions, and just clear my history and just start fresh. Same thing if on the graph, Menu, Actions, delete all, and it just helps me to start everything fresh. You don't have to do that, but I like to do it. So there are a lot of different ways we can do this, and I'll kind of show both ways, but this says for each of these functions, find the value of f prime of x, and then determine if the function is increasing, decreasing, or has a horizontal tangent or vertical tangent. Now, our calculator won't be able to do this part. We have to interpret that part. But what our calculator can do is find the derivatives quickly. So one way to do this would be to type these all in. So for the first one, and I want you guys to do this on your calculator, follow along. It's good practice for you to do it on your own calculator. Getting that kind of muscle memory and the process of doing it will help you to remember it. So please, pause the video as you need to and just follow along. And everything that I type into my calculator, I want you guys to type into yours. So we're gonna have 3, and then the E button to the X, then use the arrow, the right arrow, to come back down, and then trig sine of X. And we're gonna enter. And now we're gonna go to Menu, Analyze Graph, and we're gonna go down to dy dx, and we're gonna type in 2. And we'll hit enter. And so it gives us 10.9318. So 10.9318. So f prime of negative, we want a negative 2, huh? So that's my fault. So actually, we don't want that one, so we'll go to Menu, Analyze Graph, dy dx, we wanted negative 2. There we go. So f prime of negative 2 was that second point, was 0 point negative, so negative 0. Point, we're always going to go to 4 decimals, 5381. So out to 4 decimals. Now, is that increasing, decreasing, or does it have a horizontal tangent? It's decreasing. Why is it decreasing? Because f prime of negative 2 is less than 0. So if it asked us to justify, that would be our justification. So that's one way to do this. Now, if we hit the button above tab below escape, if we graphed it, we could also do the derivative using that whole f1 of x. But let's just say we didn't want to graph it. So let's pretend I hadn't graphed this. We can just, left of the catalog, the book, we can go to our derivative, and we can say we want the derivative of x, and then we just type it in. 3 e to the x, and then trig sine of x. And then now this is going to give us the regular derivative, but we want that derivative control equals at, we want the derivative at x equals negative 2. Now, if this happens, this is what I talked about in the previous video. It's not a fraction, but it's also cosine of 2, e to the negative 2. We don't want to write out that number. We want it as a decimal. So if you get anything like that, always just hit Control Enter. So Control Enter. Now it gives it to me as a decimal, negative 0.5831. That's what we had. So Control Enter is your friend. Another thing I do want to point out, this wasn't in our intro video, but I see this mistake a lot, is students will write like x, y, and that is actually a new variable. So you can have any variable, like you could have a variable for Steve, and you could store Steve as 3, and anytime you type in Steve, it'll be 3. So if you want x, y, make sure you do x times y, and now they're both their own variables. That's very, very important to remember. So if you look at up here, it shows 3 times e to the x times sine of x. It's good practice to just always put that time symbol in between them. So now, this next one, I'm still on number 2. We're still using the same 3 e to the x. So what we can do is we don't have to retype it. We can go up, use the up arrow, and just hit enter. And enter will bring it back down. And we can delete the negative 2 and type in 1. Now, I'm going to hit Control Enter because I know that I want it as a decimal. So I'm going to hit Control and then Enter. Oh, I guess I didn't hit Control. Control and then Enter. There we go. And so we get 11.2681 right to 4 decimals. So f prime of 1 equals 11.26814, so 2681. That's positive, so it's going to be increasing. Now, you don't need to write, it didn't ask us to justify, so I'm just going to write increasing, but we know why did we pick increasing? Because f prime of 1 was greater than 0. So you don't need to write this in parentheses every single time, but for the first few, I'm just doing it because it's our notes. And then when are we going to have a horizontal tangent, by the way? Horizontal tangent is going to be when f prime of our c of our number is 0. And our vertical tangent is going to be when f prime of our c is undefined, or basically 1 over 0, right? When the 0 is on the bottom, or a number over 0, right? But basically it's going to be when it's undefined. Okay. Oh, I did say give a reason. I said give a reason for answer. So our reason will be the parentheses. Okay, our next one, we're going to again do the derivative, the d dx. And you can actually go to the menu, calculus derivative at a point, but I like just typing it better. To me, it's faster. So control ln. Actually, we want this to be a dividing, so before I do that, I'm going to go control divide and get that nice pretty fraction. Then control ln, and then trig, we want cosine of x divided by x squared. And then outside of our parentheses, we're going to do the control equals. We're going to choose at. We're going to do at x equals, and again I'll do the control divide, at x equals pi over 3. And then I'm going to this time hopefully hit control enter to make sure that I get this as a decimal. So now we have this as a decimal, and we get negative 0.3722. So f prime of pi over 3 equals negative 0.3722, or 23 if we want to round that last one. So every now and then you'll get this little error symbol, and if you click on it, it says warning, the domain of the result might be larger than the domain of the input. And so it's just a warning to you. The reason for that is ln of x is only for positive numbers, so just giving you a warning, hey, just double check your answer. Okay. So this is less than 0, so it's decreasing. Why? Our reason is because f prime of pi over 3 was less than 0. Okay. Next one is ln of cosine of x over x squared again, but just changing it to at pi. So in our calculator, we're going to hit the up arrow twice and change this to at x equals pi. Oh wait, we don't want control, so we're going to hit escape because I didn't want control. At pi. And then again, I'm going to hit control enter because I know I want to get the decimal version of this. And this time we got a non-real result. Okay, and the reason we get a non-real result here is because the ln of basically cosine of pi, if we remember on our unit circle, cosine of pi is over here. It's at negative 1 comma 0. And so we want to be careful when we get these non-real results of, is it actually a vertical tangent, the undefined, or is it just doesn't exist? And so ln of negative 1 just doesn't exist. There's nothing on that graph, right? The graph of ln of x looks like this. There's nothing over here at negative 1. So that's why it doesn't exist. Now, some questions, what they'll do is they'll say, like, we want the ln of the absolute value of cosine of x. This one didn't, so we're not going to do that, but I just want to show what that would look like. Is if we had the ln of, to the left of the book, the absolute value sign's up here in the top right corner. So if we had the ln of absolute value of cosine of x, this would have given us an answer, right? And we would have gotten 0. So our answer would have been 0. But because we didn't want the absolute value, we had the regular, it was non-real result. So we're going to just say f prime of a does not exist. And this is kind of actually NA, okay? It's not a vertical tangent. The vertical tangent is when we get 1 over 0, or a number over 0. So this wasn't 0 in the denominator, right? We could plug in, even think about it. like we could plug in pi into our denominator. So it's not that. If you want to double check it, a good place to double check it would even be on the graph. So what you could do is we could graph the derivative. So to graph the derivative, I'm going to go to menu. I'm going to go to actions, delete all. And in tab, we don't want to graph the original, we want to graph the derivative to see what that derivative looks like. So if I go to the derivative, right, and the reason I'm doing this is because I got the DNE, and I want to just double check, wait, was this a vertical tangent, or was this actually a full-on DNE? So we could graph that, and actually even faster, if I'm being lazy, would be we could use the copy-paste. So we'd come up here, and inside the parentheses, I'm going to shift highlight that, Control C, and then over here, Control V. So here's our derivative. And it's kind of weird, but it basically has these, if we look at it, it has these sections that are just blank, and then these sections that are 0, and then this kind of section in there. So it's a little bit weird, but since it's a full-on blank area, that's probably undefined. The other thing we could do is, instead of graphing the derivative, oh, I didn't graph the derivative, I just graphed the original. So actually with the original, that's even better, is with the original at, if we do that tab, that graph trace, if we went to pi, so if we plugged in pi to see what is happening at pi, let's zoom in a little bit. So I zoomed in a little too far. There we go. So if I go to graph trace and I plug in pi, right, 3.14, but we're going to use the pi button. It's going to show us at pi. It's just the graph is undefined. This is the original graph is undefined. So it's not a vertical tangent. It's undefined there. And if we wanted to, we also could use the derivative. So we could do the derivative. We could graph the derivative. And then Control V. And the derivative, again, it has this vertical asymptote, but then it has this whole big blank section, right? If we go back to our standard zoom, we see that we have this whole blank section here where there's just nothing, right? Between this vertical asymptote and this vertical asymptote, there's nothing. So that's why we got the NA. It's a little bit weird, so that's why I want to talk about that one a little bit more. Okay, our next one, so we're going to do the same process. So the derivative with respect to x, oops, come down here. So if you ever have that happen, my cursor was up here, we just need to bring the cursor back down to the bottom. Okay, so derivative with respect to x of e to the trig to the tangent of 0.34x. Okay, and I forgot the at part. So that would be the actual derivative, but we want control equals at 0, x, but not at 0, we need to put at x equals 0. We need to always have the x equals. And we get 0.34. So in this case, f prime of 0 equals 0.34. Oh, up here I wrote a, that shouldn't have been a, that should have been pi. So f of 0 is 0.34, that's increasing. Why? Because f prime of 0 is a positive number, it's greater than 0. And our last one, 5 sine squared of ln of x. So we're going to do our same process. The derivative at x of 5 trig. Now, remember, we cannot write sine squared like that, so before I put in the sine, actually, we're going to put a parentheses. So we're going to put parentheses sine of control ln of x. And after, we got to be careful with our parentheses because there's a lot of them. But basically, it'll kind of show you which ones they're matching with. So if I do like my closed parentheses, it'll hopefully tell us which ones it's matching with. But if we look at 1, 2, 3, it's after that third parentheses, that's where we're going to put the squared. So this squared is going around the sign. Okay, and then we want control at, and we're going to evaluate this one at x equals 1. And whenever you type these in, you just want to kind of double check that it looked correctly up here. And so we get 0. So f prime of 1 equals 0. That's going to mean that we have a horizontal tangent. So we have a horizontal tangent. And why? Because f prime of 1 was equal to 0. Now, I didn't actually do any of these that were vertical tangents, but one that might be a vertical tangent, really anything with a fraction, a lot of times can have a vertical tangent. So maybe if we had, something like x squared minus 4 divided by like 2x minus 6. And if you look at the denominator, when x equals 3, the denominator is going to go to 0. So if we did this one at x equals 3, you'll get a negative infinity. And the negative infinity, really it should be dne, but the way your calculator does it, and it even gives us this error. It gives us this error and it says, hey, the domain might be larger, gave us the error. You see that negative infinity, it's really a dne. Like the derivative is not negative infinity, it's actually just dne. And that would be a vertical tangent. So, sorry, a vertical asymptote. Oh, no, this is a vertical tangent. The vertical asymptote, that's my fault. Vertical asymptote happens when the derivative goes to 0. So what might happen would be, we might have something like this actually. X, the cube root of x, right? The cube root of x has 1. So if we go here, the cube root of x, this one at x equals 0. Oops, messed that up. There we go. This one gave us an undefined. So this guy was giving negative infinity with an error. And the reason we got an error, it's actually not a vertical tangent, it's a vertical asymptote, right? The original graph doesn't exist. You cannot plug 3 into the original graph. Like 3 just doesn't plug in. And so it kind of freaked out and it says negative infinity, but it's because it just didn't exist. But here I can plug in 0 to the cube root of x. It's 0. But the derivative has a vertical tangent line there. We're going to talk about this we talked about this in the differentiability video. So where we have that vertical tangent line, right? So kind of just down here somewhere. The cube root graph looks like this, where at 0, it kind of goes vertical just for a little bit. And so basically the x value exists, but it has a vertical tangent line. Why? Because if I took the derivative of x, cube root of x, right, rewrite it as x to the 1/3. When we take the derivative, we get 1/3 x to the negative 2/3, which means the derivative has a fraction, 1 over 3x to the 2/3. So when we plug in 0 here, we get dne. We get a 0 in the denominator. Whereas in the original, we were allowed to plug it in. So that's when we get that vertical tangent. Okay, it's pretty rare, but just kind of going through it. So I know there were some weird parts of this video, but most of it hopefully should have been pretty easy. But I do want to discuss those weird parts just for when they do come up. So moving on to page 145, we have essentially doing these into word problems. So just kind of review, we should know this already, but when the value of a function when the value of the derivative, is positive, we know the function is increasing. When it's negative, it's decreasing. So whenever we're speaking of these increasing or decreasing, they're always at a certain rate. Okay, so we know that basically what we're going to connect that to is that the derivative is the slope of the tangent line, and that's our rate. So those words are all kind of connected. So derivative, slope of the tangent line, and rate. Those are all going to be connected. And we're going to get these into word problems, and they're a little bit tricky at first, but once you get the hang of them, they actually are a lot easier. And they're a big part of the free response, so we really have to get comfortable. I know we don't like word problems traditionally, but a lot of these follow a very specific pattern. Now, the way I wrote this first one, the way this is written, I don't like it. So I want us to cross out the word entering, and the AP test I don't think would write it this way. And let's just say the number of people inside a concert can be modeled by the function f of t equals 560 e to the sine t, where t represents the number of hours after the gate are open, and an AP test might even add, and f of t, is or represents the number of people inside. They kind of already said that, but just to kind of hammer it home. Or f of t, maybe they'll use like units. F of t is in units of people. Okay, so just kind of adding that on just a little bit to help us out with this one. So find the values of f of 1/2 and f prime of 1/2. So we're going to use our calculator for that. So I went ahead and I cleared out the history of my calculator, but we're just going to type in the equation that we have. So our equation was 560 e to the sine t, and we want to plug in 1/2. So we can just type in 560 e to the trig sine of t, and you can use x, but I'm going to use t, and then we can go control equals, go to at t equals 1/2. Now it gave us this with the 1/2 and the e and the sine, so if we don't want that, we want it as a decimal, which we probably do, we're going to go to control enter. So 904.48. Now we always go to 4 decimal places, and some of these problems might say, round to the nearest whole number, but this one didn't, so we're not going to. So we're going to say f of 1/2 equals 904.4819. And again, it's a little bit weird because you don't have you can't really have a decimal of a person. So you might, say 904, right? Most problems would probably say round to the nearest whole number. But again, just because they didn't, I'm going to just use the decimal. So what this means is f of 1/2 equals 904. What was the f representing was the number of people inside the concert. So we'll say this represents that 904. Now we always want to use units with these. It says using correct units. That's a really big deal. So 904.4819, that's the what, right? The what, people, what have they done? They're inside. So people are, right, we're going to use the words that they use. People are inside a concert, and that's the what. We always also need the when. So at time equals 1/2 hours. You could say 30 minutes, but I always just make it easy and just stick with 1/2, and the units are hours. That's the units they gave us. So f of 1/2 was the number of people that's at 1/2 hours. And again, if they said round to the nearest whole number, we just said 904 people. Okay, next is for f prime. So f prime of 1/2, and that's going to be equal to, now what we're going to do is we're just going to basically go to, on our calculator, to the left of the catalog, click our derivative symbol, click x, and actually we're going to do t because we're using t. Now you could use x, but then you would need to change it to sine of x, and that's okay. Now I'm going to just come up here and I'm just going to copy this part. Don't copy with the at, because the at part needs to go outside. So I'm going to go ahead and click Control C and come down here, and we'll click Control V. Now outside, we're going to go to Control equals, we're going to go to at t equals 1/2. And again, I got something weird, so we're going to hit Control Enter to turn that into a decimal. So 793.7575 or 76. Now, this is the derivative. This is where kind of, I'm going to make this a little bit bigger just so we can talk about this, is up here we said that the slope was a rate. Okay, the slope was a rate. That's very, very important. Okay, we're always going to want to use the word rate when we're doing these kind of statements. So this represents the rate. Now, people could be leaving or entering. So the rate that the amount of people inside the concert is changing. Now, that's the what, but we also need the units. So what are the units? The units would be in people per hour. Okay, the way units always work, this is something we're gonna get into, but the way units always work is kind of the original amount. Like the original would be just some like blank units. Okay, then our first derivative, like our rate, our f prime of something, would be units per a unit of time. So those same units per a unit of time. And if we take the second derivative, we'll get there later, those are going to be in a units per a unit of time squared. So our original was in people, right? But our derivative is going to be in people per the time, so per hour, right? Kind of like think with a distance, right? Like if I walked 5 miles, that would be how much I walked. But then if I wanted to know the rate of me walking, that would be like my speed. I'm walking in 5 miles per hour, right? The per hour is for my speed, okay? So it's changing in people per hour, that's the what, and then we always need the when. At time equals 1/2 hour. Okay. Now, another way you could have written this, possibly and still get full credit, would be to say, 793.7576 people per hour are entering the concert. Why entering? Because it's positive. If it was negative, it would be leaving at time equals 1/2. This is a little bit more precise, right? Like they're entering the concert. But to me, I always almost kind of go with sentence starters, and I'll kind of give you some sentence starters later on when we do more of these. And my sentence starter is just to use that it's the amount that's changing. Okay, so it's what did we have? We had people inside the concert, and that is they're changing. So they're changing at that rate. And that kind of eliminates the need to worry about is it increasing or is it decreasing. Okay, now how many people have entered the concert? And again, I don't like this wording, so let's say how many people are inside. So how many people are inside the concert 2 hours after the gates are open? And is the number of people increasing or decreasing? These are going to be two different ideas. So how many people are inside of the concert? We're going to write f of 2 equals. On the AP exam, these free responses, a lot of times they have more than one question. So if we look, there's a question, and there's a question. So we're going to have two different answers. So f of 2, that's going to be from my original. So not the derivative part, but the original part up here. We're going to come up here, highlight it, and change this to 2. And I know I need to hit Control Enter. So we get 1390.24. 2435. And again, most questions would probably ask us to round this to a whole number, but since they didn't, I'm not going to. So 1390.243, basically I'm going to just say people are inside concert at t equals 2 hours. So I'm just going to rewrite it. Okay. Now, is the number of people entering increasing or decreasing at this time? So this is really important. As soon as we see the words increasing or decreasing, or we see something like a rate, that's no longer talking about f, it's no longer talking about our original, but it's talking about the rate matches up with the derivative. So when they say increasing or decreasing, just like how we did it a couple chapters ago, when we took the derivative, set it to 0, did a number line, found out if it's positive or negative, it's the same concept. For this one, we want to find f prime of 2. So we're going to find that value for f prime of 2. So we're going to come back up here to where we had it as a derivative, and we're going to change our 1/2 to be 2, and hit Control Enter. We get negative 578.5454. So negative 578.5454. And so we can say the number, we're going to just rewrite it how they wrote it, the number of people. And again, I'm going to, this was just a bad, this shouldn't have said entering, it should have said inside. So the number of people inside is decreasing. Now, why is it decreasing? So it's decreasing at time equals 2 hours. Now, why? Because f prime of 2 is less than 0. We don't need to write what it is, we have it right there. So we always need the kind of the what is that it's decreasing, the when is that it's at time 2, and the why is because it's less than 0. So one more question just to kind of hopefully practice this one more time. After being poured into a cup of coffee, the coffee cools so that its temperature, T, big T of little t, is represented by the function 70 plus 110 e to the negative t over 2, where T is measured in minutes and big T is measured in degrees Fahrenheit. So a big thing that we know that this is the original function is that there was no like degrees Fahrenheit per time. If it had said like per minute, that would have been the derivative, but it doesn't, so this is our temperature. So what is the temperature 5 minutes after it has been poured into the cup? That's just going to be T of 5, right? So we're going to just come over here and type in 70 plus 110 e to the negative t divided by 2, and then put the right arrow so we're down here, and then control equals at time equals 5. And I know I want a decimal, so control enter. 79.0293, 79.0293. And we're going to use their units, which were degrees Fahrenheit. And we don't need to show any work. It's a calculator question. We're allowed to just type this into our calculator. Now, is the temperature decreasing faster 1 minute after it is poured or 3 minutes after it is poured? So as soon as we see the word decreasing, we know that that is a rate. That's a word for a rate. So we don't want t of 1, we want t prime of 1. And we want t prime of 3. So we're going to come back up here, and we don't want to plug it into the original, we want to plug it into the derivative. So we're going to say the derivative with respect to t. Now you could use x, but you'd have to change it to an x. And here, I'm going to do this. I'm going to just hit enter, but I'm going to get rid of the at part. Right? Remember, we want the at part after the parentheses. So now after the parentheses, we can go to control at time equals 1. Control enter to make this a decimal. And while I'm at it, I'll do at time equals 3. And control enter, or you can even just put the decimal right there. So we have negative 33.3592. Now, what would the units here be? Okay, the units would be degrees Fahrenheit per minute, right? The per minute, because it's that first rate. And the next one is negative 12.2722, if we round it. So negative 12.2722. And so we can say, kind of, the give a reason for our answer is basically within the question. So we don't really have to say much because we showed our work. But you could always, basically write out which one's bigger. So the temperature is decreasing faster at time equals 1 minute because you'd say something like the absolute value of t prime of 1 is greater than the absolute value of t prime of 3 since they're both negative. Or you could say, just t prime of 1 is less than t prime of 3. Maybe you add is less than 0 or they're both negative, but honestly, we almost don't even really need the because you have the work. Right? You could even just say because t prime of 1 equals negative 33.3 and t prime of 3 equals negative 12.2. So it's obvious that that one's decreasing faster. So anyways, that's just kind of looking at how would we convert these to the word problem using our calculator. I didn't do this, but I do want to show very quickly one thing we could have done, kind of jumping back up to number 7. we had just typed these in, but hypothetically, you could have actually typed in your calculator the 560e to the sine x, and when you graph that, the original graph is going to look like it's nothing, but I did type it in, 560e. The reason it's not there is that 560 number is so big. If I go to window fit, zoom fit, now I can see it. And so what you could have done, if you had wanted to, is instead of typing these in like this, like how we had it, typing it in at 1/2, you could have actually typed it in at f1 of 1/2, and you get the same answer, right? Or control enter to get the decimal, right? The 904, that's what we have. And same thing we could have done. You can't do prime, but you can do this derivative notation. So d dx of f1 of x, and the whole at, this one does need the at x equals 1/2. And so we could have done this and gotten the 793. So that's how you would use it, kind of integrating the graph with the calculator side. So hope this helps. Email me if you guys have any questions on this, and we can go over it. I know it's a little bit of a longer video, but it's just very important information of how we use our calculator to start answering some of these questions.